Cities are complex ecosystems made up of people, services, buildings, transport networks, communication networks, vegetation, and many more systems. Research often focuses on one particular aspect, such as people's habits, or buildings, street flows, or building management, due to how complex the system is and how many scales it has. Starting with the smallest scale, you have the individual person and their immediate surroundings, and then the building scale, such as the house or office. Then you have the neighbourhood scale, which is a collection of buildings, the city scale, which is a collection of neighbourhoods, and then the regional scale, which is the city and its surrounding areas, going up to entire countries and ultimately going global. To understand a city and how it works, you have to have a variety of data, abilities and specialities for all the different physical scales. Each city has a unique story to tell, and no two cities work in the exact same way. Cities are a mixture of old and new buildings, serving a variety of purposes and people. All of this can be difficult to keep track of, so data is often overlaid onto a city map. You can map out building density, or building age, or maybe vegetation spread, or have a look at the sky view of the streets, or instead focus on people and look at the population spread, or look at differences in demographics across the city, or the overall population density. You can map these variables alongside transport networks and land use fractions to find previously hidden connections between different variables, or perhaps highlight areas that are more likely to have afternoon shade, or cooler regions within the city to provide guidance for vulnerable groups during heat waves. Or you could highlight areas prone to overheating as key targets for investment and mitigation measures. This type of behaviour could be used for looking at energy usage behaviours, or planning for the introduction of renewable energy systems through wind flow mapping, and using shadows to pick ideal buildings suitable for solar panels within the city. The possibilities are nearly endless, but data access, data quality and computing capabilities may limit the ability to use large datasets for finding out details. Detailed, dense information and detailed models of the city often means big data, and not everyone has access to the resources required to process and run models on this scale. Often assumptions have to be made, or some detail may need to be reduced, such as removing street furniture or simplifying the representation of the building shapes. Different techniques can be combined to get a balance of both performance and detail. Eventually, this may mean each city has a digital twin, with all interconnected processes modelled. But until then, we need to keep improving our understanding of the cities and all the processes involved, keeping in mind that although physical processes may be similar across two cities, the end effect may be completely different due to each city's unique characteristics and layout. By combining local knowledge and big data, cities can be modelled, understood and improved upon for future generations to come.